The broadcast is now starting. All attendees are in listen-only mode.
Welcome. I'd like to thank everyone for joining us today for part 3 of our corporate webinar, Florida Peninsula. This is part 3 on formulas and functions. And it's brought to you again by Excel and Access, which has provided expert consulting, programming services, and certified training solutions to business, government, and education for more than a decade. Once again, your presenter and trainer is Dennis Taylor. Dennis is the author of Teach Yourself Microsoft Excel and the co-author of 4 other books on spreadsheet software. He's developed customized Excel courses for specific clients and has recorded over 50 different training courses on Excel topics for Keystone Learning Systems and lynda.com. He has also led numerous training sessions with Apple, IBM, Lexmark, Texaco, Raytheon, Northrop Grumman, and various federal and state agencies. And with that, Dennis?
Thank you, Joe. Hello, everyone. How can we talk about Excel and not talk about formulas and functions? It's the centerpiece of what a lot of us do. And although some of us don't necessarily have fond memories of high school math, a lot of the formulas that we work with in Excel are addition and subtraction, a lot of them straightforward, particularly in the accounting arena. It's not to say that Excel doesn't have the sophisticated tools for more complex formulas. It certainly does. And built into Excel are well over 450 functions, and we'll be talking about a lot of them today. Certainly one of the major ones is VLOOKUP. It gets a lot of attention. Anytime you're trying to match up data from different worksheets, that's the function to first look for. It also has other uses as well. We'll be talking about it. 2 follow-up functions. I call them follow-up, but books don't refer to them that way. The match and index function also have a role to play when you're trying to reconcile differences or find data on different worksheets, different locations. Those kinds of functions, by the way, are not really math-based, and so I think sometimes you'll, even if you might have that little block about things getting too intensely mathematical, all of these functions you won't have to worry about when it comes to that aspect of it. We're going to start off with a few shortcuts, a few tips, and then talk about the if function. That's also an important function, too. It opens the door to a different kind of thinking about Excel, almost a programming-like feature that allows us to come up with multiple answers depending upon conditions. And at times it can be very simple, at other times a bit complex. I'll give you examples of both. I'm going to go to a worksheet here that's a real mess. I made it a mess on purpose. When I originally found this worksheet, it wasn't in such great shape, and I made it even worse. To use it as an example of, sometimes when people are preparing things, they don't finish it, or maybe something intervened, they got switched to another position, and here's what we're left with. This is some kind of a pricing sheet, and we don't know what's going on, and it would surely be helpful if we could find out kind of quickly. And in the session 2 days ago, I mentioned Control tilde. Don't use the Shift key. Tilde is that funny-looking key, and I've got it right up here on the in cell C1, upper left corner of most keyboards. And so in any worksheet at any time, and certainly with causing no damage whatsoever, if you press Control tilde, all column widths are doubled, and in the process, wherever there is a formula, you will see a formula. For example, in cell B7 here, B19, and so on. And press Control tilde again, right back to normal. It certainly doesn't tell you everything you need to know about this worksheet, but it gives you some insight, and it gives you some sense of what it is you're prepared to tackle here as you try and understand what's going on here. And another feature, too, easy to get to, start with the active cell on any one cell, not 2 or 3, but just one cell. And on the Home tab in the ribbon, off to the right, the Find and Select button has a choice called Formulas. As soon as you click it, all the cells with formulas are highlighted. And you can certainly add a color to them if you wish. I'll do this with the fill color bucket on the font, in the font group on the Home tab right here. There we are, and do that. Now, that's not a dynamic feature. If I erase the content of that cell, it stays yellow, or if I write a new formula here, it will not turn yellow. So periodically, you might want to run that feature again. And again, it's from the Home tab, the far right button, Find and Select, and then Formulas. If you want to go a step further and highlight just the cells that have numbers, you could do that too. It takes a few more steps, but essentially we start at the same place. Once again, make sure the active cell is on one cell only, and again off to the Find and Select button, and choose Go to Special. Then you can choose Constants, And the boxes below here, we want to uncheck the box for text and logicals and errors and click OK. And now we've highlighted all the cells that just have pure numbers in them. Now they could be ID numbers or computational numbers. We can't differentiate that at first. Here too, if you want to leave these marked on the screen, we could come over to that fill color bucket again and maybe use another color for those or something. So sort of a pink or tan, whatever that is. Anyway, you don't have to add the colors, of course, but that's going to be handy at times. Now, another feature that's handy too is an auditing tool. I want to undo my last two actions with Control-Z and Control-Z and just click somewhere. If you've worked with this worksheet for 5 or 10 minutes or so and you're trying to get the hang of it, what's going on, you might begin to realize that cell B3 is pretty important. And you've already discovered that cell B7 depends on it. And how about cell B10? Well, it depends upon B7, therefore it depends on B3. Trying to track the dependencies of a cell, if you try to approach it manually, it's going to take you a long time, and you probably always have that nagging doubt about not having found everything. Fortunately, there's a great tool available. It's on the Formulas tab in the ribbon. And I'm using Excel 2010, as I have been in the last two webinars, and in Excel 2007, Excel 2013, you'll find this feature in the same place, Formulas tab in the ribbon. So the active cell right now is at B3. I'm going to click the button Trace Dependence, and that points to all the cells that have a direct relationship in their formula to cell B3. But don't stop there. Keep clicking Trace Dependence over and over and over again. If your speaker is on, you'll hear a beep at some point. Otherwise, you'll see the lines, new lines stop appearing. Every cell there that's got a blue dot or arrow in it has a dependency on B3. And of course, many of them have other dependencies as well, because formulas sometimes gather data from multiple cells. So I sometimes jokingly say in live presentations, next thing to do is print this to show that you've been busy. Now, obviously, it didn't take very long to get here, did it? If you're going to be tracing the dependencies of another cell, you better get rid of these arrows. And that's interesting why that happened. I'm not sure what happened there. I meant to say if you click remove arrows, and seemingly I didn't do that, but it happened. Okay, we'll do it again. There we go. Remove arrows will get rid of it. But before I do that, I want to point out one other thing. As you're looking around the screen, you might see a dashed line. I say might because it isn't always the case. This actually points to an icon, and after a while you might not, or you wouldn't recognize it first maybe, but that is pointing to another worksheet. So there is another worksheet, either in this workbook or in another open workbook, that has a dependency on this cell. And if we double-click the dashed line right here, let me first zoom in on that so we can see it even larger. The dashed line is coming out of cell G5. Here's the dashed line. I'm going to double-click it. And the dialog box says that over on the profit sheet in cell K1 is some data that's being pulled in by this cell here, this G3 here. Actually, I'm sorry, it's the reverse. It's always a little tricky to say. On this profit sheet, which we're going to look at momentarily, in cell K1 is a formula that gets data from cell G5 right here. This current worksheet is called Find Formulas. So if we double-click this or click OK, it'll take us there. So here we are on this other sheet called Profits, and here's the formula in question, off to the right there. I'll double-click it. So what is this saying? Get data from cell G5 in the worksheet called Find Formulas. So as we go back to that worksheet called Find Formulas, you would never know by looking at this worksheet, unless you happen to have written the formula or somehow you stumbled across that when looking at the other sheet. You can't tell by looking at a worksheet if other worksheets are getting data from this worksheet. So this does point out, and you could say it's sort of happenstance or by accident that we found it out, but we did find it out. One of the cells that depends on B3 here actually is on another worksheet. So the ability to do this with this feature is pretty amazing, thinking of how you might not even discover that for a long, long time.
Good morning, Dennis. This is Christopher.
Hi, Christopher.
Hello, how are you?
Fine.
Does anyone have any questions so far? If you do, can you please let us know? I know Drew wants this to be a more interactive session, so if you please have questions, please let us know. Okay. Thank you, Dennis.
So once we had more or less taken care of this issue here and possibly printed it, maybe not, we could remove the arrows. Now the reverse situation could be just as important, maybe more important in some cases. There's sort of a bottom line number here. This is in cell L23, the total. Where does that cell get its data from? It's got a simple formula in it that simply points to two other cells, but each of those cells has a formula. And I think you get the idea here. You might think of it as working backward. We'd like to find all cells which, if altered, will affect this total or can affect this total. So the reverse of dependence is trace precedence, or is precedence, and the command is trace precedence on the Formulas tab right above dependence. Trace precedence. Here too, don't just click it once, keep clicking it. And we have lots of situations, not quite as many as the other one, but all of these cells with blue dots, if altered, could have impact on that grand total. Notice that I didn't say will. It depends upon the nature of the formula, but let's say that they could, if altered, change the result in cell L23 down there. So those are valuable tools, auditing tools, and again, it's I don't envy the task of auditors. This is tough work, and this feature certainly helps remove errors.
Hey, Dennis, we're going to unmute the audience.
Yes.
So they can just ask questions live, because that's what Drew
okay.
wanted me to do, and so we're going to do that now.
Okay, that's fine. Do speak up at any time if you have questions.
Are there any questions so far? And okay, it looks like 3 people are live on the mic, and then Kathleen is looks like she's muted. Could everyone say hello if you could hear me, please?
Hello.
Okay, thank you. So if you have any questions, please interrupt Dennis and ask him live. Thank you.
Okay.
No, I can't hear anything now.
Okay, we're going to fix that. Take 1 second. I'm sorry.
Are we ready? I'm not hearing anything. Are we ready to proceed?
We're good.
I think we're ready.
Okay. In any worksheet at any time, keep in mind, when you highlight 2 or more cells with values, you do see totals at the bottom of the screen, possibly as many as 6. This is called the status bar. In the right side of the status bar, you're likely to see these various statistical measures down here. If you right-click the status bar, you'll see these right here, and I usually leave them all checked. You can turn some of them on and off. But if we click the entire column, we now know the total for that column, as well as the average, the high, the low, and so on. That's handy information. Now, what if, as a complement to this, and actually a little bit different, what if we always want this total there on the screen at all times? Basic formula writing in a certain sense, but a shortcut or two. We want to use Autosum. I'm going to press Alt equal. I certainly don't want to add up those 2 cells, but I do want to add up the data in column J. So rather than typing J2 colon J69 or dragging down the column or holding down Shift or something, we'll just click column J. Enter. We've got an answer here. Let me zoom in on that because we don't need to see too much of the screen right now, but see that part certainly. So all I did, again, was to create a formula and adding up everything in column J. Now that's easier to read once you get used to it, and furthermore, it has the advantage of, as this list grows, we don't have to change this formula. And even if it were to shrink, we would have to change the formula as well too. For average, we could do this slightly faster. If you click the arrow that's associated with Autosum, now right now I'm on the Formulas tab, it's on the left-hand side. If you're on the Home tab, it's off to the right. If you click the drop arrow associated with Autosum, right next to it, you could choose Average, as I'm doing here. I don't want to average the cell above. I do want to average column J. I'll simply click column J. And once again, we complete the entry. And we can verify that again. If we click column J, we should see that same number at the bottom of the screen in the status bar. Median, it's going to take a bit more. It's a common function for some people. As you're typing function names, no need to capitalize them. Left parenthesis here, we need column J. And the right parenthesis, Excel will handle for us. Anytime we're putting in a function, it's the function being used by itself with a single set of parentheses, we don't need to type the right parentheses. Simply press enter. Just the tiny little things that speed up data entry there. So using entire column references often is a good way to write formulas in a simpler way. It's all based on the supposition or the knowledge, let's say, not supposition, but knowledge, that you know your data well enough to know that there's nothing else in column J except these salaries and the head and the label on top. There are no interim subtotals in there, no grand total on the bottom. If that were the case, these formulas, of course, would not work. But we'll use some other examples like these too as we work with entire columns at times. Here's a different worksheet, 2 sheets to the right, called City Sales. Let me zoom in on this a little bit. If we wanted to get an East total, and that would be the New York and Boston entries there in rows 2 and 3, we could again start with Autosum. I'll just press Alt equal. But this time I'm going to drag across rows 2 and 3. Now that notation certainly looks funny too. It means rows 2 and 3. It certainly has nothing to do with the values of 2 and 3. And as I press enter, there's an answer. And as we drag across with this and hold down the mouse across rows 2 and 3, we can look in the status bar and there too verify our total. Way off to the right at the bottom here, sum 267,108. It's the same total we see right here. And I'll just do one more here, but if we were doing the Midwest, the 2 Midwestern cities on our list are Chicago and Cincinnati. So we'll press, again, Alt equal maybe, sort it that way. But this time, click 5 for Chicago, then a comma, and click 10 for Cincinnati, and enter. So we've got that look. Again, looking a little unusual. And we could verify that total as well, too. And we would know in both cases here, of course, there's nothing in rows 5 and row 10 except the numbers we see in the city names. Everything off to the right beyond the numbers is blank. So this is less likely to be needed, but you can use entire row references as well as the more frequently used entire column references. And a worksheet here called Autosum. Remember, too, when you right-click on the arrows in the lower left-hand corner, you can see a vertical list of the sheet names. Now, I can see this across the bottom, too, but sometimes you see it better this way, or you just might have trouble finding it. Quick mention or two about Autosum. If we want a total right here, most people will click the Autosum button. That's just fine. And then what? Enter. Okay, not a problem. You might use the button, as I did there, but why not double-click Autosum? Makes it a tad faster. Remember, there's the keystroke shortcut is Alt equal. Sometimes you might want to highlight the data first. Anytime you highlight vertical data, if you use Autosum, the total will appear below it. I'll press Alt equal this time. Do it that way. If we wanted totals here, we can press Autosum or Alt equal once. Got it right there. We can do the same thing down here. Or, backtracking a little bit, if looking ahead, if we wanted totals on the right and the bottom, we can highlight the cells this way and press either the Autosum button or Alt equal, either way. Handy and fast. Keep in mind, too, you can use the sum function to gather data from multiple locations, even though it might seem a little weird. So if I begin with Alt equal. You know, another thing, too, to think about, anytime you're typing equal sum, left parenthesis, couldn't you have pressed Alt equal a lot faster? Alt equal makes a guess, and sometimes a bad guess, but simply ignore it. So I want to type equal sum, left parenthesis, but instead I'll just press Alt equal. I don't want to add that data. I do want to add up the Texas data from the right, so I'll start highlighting it. Now I want to add up some other data, comma. I want to add up the domestic data down here. Now, admittedly, this would be a strange combination of numbers, but I can put in a comma and add up some others as well, too. A comma and throw in a number if I wish, 100, and go on and on and on and on. So not that you would ever write a formula quite like this, but it does point out the idea that you can add data from different locations. Something that might make sense here is, for whatever reason, somebody says, I need the California and Florida totals only together. Well, we could start over right here and simply say, let's highlight California, comma, and then Florida over there. So we did it. And that's the total. When you've got parallel sets of data like this, sometimes you begin to recognize there's some shortcuts. Let me preface this by saying, in a totally different context, if you were putting in some city names somewhere, maybe you're creating a list. I'll do this maybe off to the right somewhere. Maybe you're putting in a list, it begins with city, and you've got some city names. They're going to be repeating. Maybe it's sales in some of your major cities or something. Imagine that in the first 2 cells here, but not the next one, but maybe in the next 3, and maybe no more until down here, another one, maybe another one down here. All of these need to be Tampa. So I'm going to type Tampa. But I won't press Enter, I'll press Control Enter. Now, we can do that with formulas as well, too. If I want totals here and totals there, let's highlight them both first. Now, if it's simply a total, we don't even have to do any typing. But whether we highlight the right side or the left side first, the technique is we highlight one side and let go of the left mouse button. Then as we start to highlight the other portion, we hold down Control and highlight it. And what can we do here? Either press the Autosum button or Alt equal if we wanted totals. If we wanted averages instead, we could click the drop arrow for Autosum, choose average. All done. Really fast. If we wanted median, that would take a little bit more work. We've got our cells highlighted. We type equal median, left parenthesis, and we would act as if for the moment we're only doing this for the active cell. That would be right here. If we press Enter, we put the answer only in column K, but pressing Control Enter puts the answer in all these cells. So every one of these is going to be a median of the 6 cells above. Now, this might look a little contrived, but on the other hand, sometimes when you're writing formulas, excuse me, you do see nearby cells where you're trying to do the same relative thing. And that's going to be handy at times too. Let's shift back to this first worksheet here. And imagine if this company is going to give bonuses to people based on their job performance. Now, the column we're going to put the answer in is column K. These cells do not have to be any wider because the answers are going to be relatively, well, 2,500 will be the big bonus. But we're going to make the column wider because as I begin to use the if function here, we want to see different aspects of it. And I want it to be large and clear. So for the moment, all we really need to see with this is the job rating. Here's the situation. This company has decided to give bonuses to people whose job ratings are 4 or 5. Otherwise, nothing. The if function, simple many times, begins with the idea of a condition or a test, a logical test. And our test is simply, is this J2 cell right here, is that 4 or 5? And we can do that in 2 ways. The greater than symbol followed by 3. All the job ratings are whole numbers, so if it's greater than 3, that means it's 4 or 5. Another way to say this, some people prefer the other way, is to put in the greater than symbol followed by equal to, and then a 4. And the way we read this is if J2 is greater than or equal to 4. So either technique works. I'll just use this one for the moment. Comma, that's the end of a logical test. Now other kinds of logical tests could be you are comparing 2 different cells to see if one is larger or smaller or equal to or whatever. Sometimes you're comparing a cell with a formula. Sometimes you're looking at a cell to see if it's equal to a text string of some kind. Lots of different comparison types here. We provide 2 answers in an if function. When this is true, the answer is, it can be a number, as it is here. It could be a formula. It could be another cell reference. It could be a text string, any of those. And the same thing applies to the answer for when that condition is false. If we want 0, we can certainly put that in there. If we want to display a space, it's double quote, sometimes referred to as the null string, double quote. If you want to put a word between there, fine. For example, you might put this in, although if you were an HR professional, you probably wouldn't. Anyway, Do we have to put in the right parenthesis? No. I'm going to press Control-Enter. Why Control-Enter? If I press Enter, the active cell moves down. That's not horrible, but I have to reposition it if I want to copy this formula. I'll press Control-Enter, and that's a sorry. Maybe we should change that, just to be a little bit more professional here. We'll just leave it blank. And that's the answer we would expect for the first person, because the job rating is 3. It's not 4 or 5. And I meant to press Control-Enter there. I'm going to double-click from the lower right-hand corner and then redisplay the formula. There it is. Simple, straightforward. We can confirm it by seeing the results on just a few cells. You could scroll up and down the column and check out others. They'd all be correct. Many, many times the if function is this straightforward. But
how many people here use the if function? Hello, Dennis.
Yes.
How many people in the audience use the if step, the if function?
I do.
I do.
Okay. Okay. Thank you.
Now, this company has changed its mind a little bit and said we should give a bonus also to people who have a job rating of 3, but maybe a lesser bonus. One thing that's not so obvious with the if function is that it actually happens left to right. In other words, when this is true, the answer is 2,500 and the logic stops, so to speak. It ends. That's it. It gives the answer and moves on to the next cell or whatever. But when this is false, the logic jumps over the 2,500 and comes behind the second comma. So at this point, the logic will only go here if the job rating is 1, 2, or 3. We can put in another if here. And at this point, when we're checking the job rating, it can only be a 1, 2, or 3. And we're checking now to see if it's equal to 3, comma. And if it is, we'll give these people $900. But if not, nothing, blank. This is an if inside of an if. It's called a nested if, and we do have to provide the extra parent, the right parent on the right side. These are color-coded. I'm not sure how well you can see that the right parent here is green, and so is this one. The original left parent is black, and so on. Anyway, we put another parenthesis on the right. I'll complete all these with Control-Enter, and we'll have some changes there. The first one's 900, and down in row 7 we see the same thing. So we've got 3 possible answers now. And the goal here is not to make these more complex, but maybe it's just based on need. Now, maybe this company says, you know, these people with a job rating of 2, they probably don't deserve anything, but just to kind of rub it in, we'll give them a small bonus of $100 or something, as if to say, gee, you could have made 900, you could have made 2,500. After the second comma, after 900, we can put in another if. We do the same, sort of the same thing all over again. If J2 equals 2, comma, we'll give them $100. Otherwise, nothing. And we need 3 right parents out there on the right side. When you're writing these, it helps to zoom in. I nearly always do editing right in the cell itself by double-clicking. You can certainly do this in the formula bar as well, but if you've zoomed in, this is larger and clearer, and you won't have any problem mistaking commas or periods and vice versa, and those parentheses will not blur together as they sometimes do. So I'll complete this with Control-Enter. Now, if I click column K, I can see what this company is about to spend on these bonuses. And look at the bottom of the screen here. It's almost $1 million, $939,000. That may have something to do with the value. In some scenarios, what might happen is, instead of these numbers being purely in the formula, they might be in external cells. And so maybe the person doing this, perhaps it's someone who works for the chief financial officer, is deciding how much money they can afford for these bonuses, but this might be a flexible number if it refers to an external cell. So that could be a possibility in here as well. Now, there's another way to use the if function too, and that is to combine it with the and or the or functions. Now, it's not necessarily, I would certainly not say it's a requirement. It's all going to be based on the logic that you need to come up with a certain answer. I'm going to scroll leftward a little bit here and expose 2 other columns, the status column and also years of service, columns G and H. For the moment, column I we don't need. I'm going to right-click column I and simply hide it. Not delete, but hide. And I'm going to have to zoom back a little bit here. There we go. Now, this company has changed its mind and says the following. We only give bonuses to full-time people, and they must have a good job rating. So let's reconstruct this a little bit. We're going to take off a lot of what we have to the right here. and reconstruct it. Still, a few parentheses on the right we will need as well. So we're not quite there yet, but I'm going to insert the word and right after the left parenthesis here. Sometimes this is a standalone function. We want two things to be true in order for someone to get the $2,500. One of them is the previous requirement, job rating has to be 4 or 5, comma, and the next one is the status, that's in cell H2, equals, and within double quotes we put full-time. The uppercase isn't critical, but why not keep it the same? The spacing certainly is. It's got to be F-U-L-L space T-I-M-E, because that's the way the entries are made there. Another double quote at the end, right parenthesis in a comma, and then one more comma behind the 2,500. So, what are we saying in English? If your job rating is 4 or 5 and your status is full-time, you get 2,500. Both of those need to be true. And if you think about it, there are 4 possibilities here. True, 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 false, false, true, false, false. Only when they're both true do you get the $2,500. So I'll complete that and copy it down the column. And pressing F2 to expose the first one. If they follow this scheme, they're spending a little under $500,000 on bonuses. The other one was close to $1 million. And again, you can look around and see what's happening here. It makes perfect sense when it's in context. And that's often the idea here with these if functions. If just thrown at you out of nowhere, when you're looking at these, sometimes you say, what is going on here? But if you've been working with the data, and not necessarily the if function, but if you know your data well, many, many times the logic just works and you understand what's going on. And we can see here pretty clearly what's happening. The only time we see 2,500 is when we've got a combination of either it's full-time in 5 or it's full-time in 4. Any other combination just doesn't work. If we were to use the word or, I'm going to put that in there, this is going to be a more popular decision by management because what are we going to be doing now? If either condition is true, so I'll complete this entry. There we are. And we see what's happening. So even the person down in row 11 there, job rating of 1 gets a bonus? Yes, because he's full-time. You might question the wisdom of the company doing this, but nevertheless, the logic is there and it's working. And here too, one more time, I'll simply click column K. And now for bonuses, it's 1.3 million. So each time, of course, you could be checking something like that. Now, although you might not see these together, occasionally you might see an and an or mix. I'm not going to suggest this is something that's frequent, but on the other hand, you possibly could run into it. Once again, the company has changed its mind and says the following. We will give you a bonus, certainly if you have a good job rating. We don't care what else is true. If you got a good job rating, you get a bonus. But if that's not true, we will give you a bonus if you are full-time and you have more than 9 years of service. That's out in column G. G2 greater than 9. So that's an and inside of an or. We need another parenthesis out there. And we should get an answer here. And it's a little trickier to decipher, but on the other hand, if you know the data well, if you've been working with it, that works just fine. So you will get a bonus if you got a good job rating. Any 4s or 5, automatic bonus, no matter what your status is. But if not, you might be full-time and have the right years of service. So that person down in row 11 with a terrible job rating is full-time and has more than 9 years of service, so it works. So you can begin to see how these possibly could be more involved, more complex. That certainly is not a goal. I wouldn't say the more complex the better. I'd never say that. But sometimes these can get involved. If that's all we wanted to do here, we'd simply double-click the boundary, the right-hand boundary of column K, and of course it only needs to be this wide. Now, there's another aspect of this too that could help. On another worksheet here, I've got a formula that's pretty bad, pretty involved. I want to zoom way in on it and find it there momentarily, off to the left. There we go. It's in cell B42. This is on the fine formula sheet. I'm going to double-click this. What a mess. Let me zoom in on it. It's a bigger mess, I guess you'd say. There it is. All right. Nobody wants to have this thrown at them. And,
I have a quick question.
Yes?
It looks like the file that you're using now is different than the one we had yesterday.
No. This is the file that I sent to Drew today it's called Formulas and Functions.
He's not here today, so I don't think we got it.
Oh. I did send it to him. Maybe he's not here today, or.
Yeah, he's not in today. So
Oh, okay. I should have sent it yesterday then. Let's see. If I could send it to somebody else, you could all have it, and certainly it's available. I can make sure you have it.
So is that something that you could send to Christopher, for instance, Dennis, and then he could forward it to the audience, or just to Drew?
I would imagine so. Yes. Let me temporarily back out of here and jump into Outlook and. I need Christopher's email, which I don't know. Oh, let's see. Maybe I have it. Let's see. I sent it to Christopher, so I'm not sure if he got that yet. But
his email is christopher@excelandaccess.com.
I found it and I sent it. I forwarded the mail I sent to Drew. I also forwarded to Christopher, so I believe he should have it. Well, anyway, I think even watching this, because you don't want to necessarily work with it, I'm not, in no sense am I going to pick this apart and say why it's good or bad, but just point to an aspect of it. This is a nested if, and it's really hard to decipher at first. But here's a little trick, and let me momentarily get out of here. When you're doing data entry, and suppose in a totally different context, if I were putting in a column heading here, if I want to put in 2014 salary, and I want the word salary to appear under this in the same cell, I'll press Alt-Enter and type salary. So it looks like that. Now, in formulas, regardless of what kind or how long they are, if you somehow want to introduce line breaks, I'm going to do this. I just double-clicked on this cell here. I'm going to click in front of the second if and press Alt-Enter. And then go to the next if and press Alt-Enter. And then the next one. And finally the last one. And even the first one, probably. Now, I'm not claiming instant comprehension, but that is a lot easier to read than what we saw before. And it's one of those things where, okay, I'll go grab a cup of coffee, sit down here, and either on the whiteboard or on a big sheet of paper, try and figure out this logic and whether it's working or not. We're not going to do that, but you certainly are better prepared to do that if you simply have inserted these line breaks. This has no impact on the result. You press return, nothing's really changed, the same answer as before. So it's a handy tool at times. And I've done this with other kinds of formulas too. This, by the way, is 4 nested ifs. 4 nested ifs. And the maximum in older versions of Excel was 7. So you can imagine how complex some of these could be. And believe it or not, apparently enough people asked Microsoft to provide even more. And in typical fashion, Microsoft responded eventually in Excel 2007 so that we can now use 64 nested ifs. I'm sure you're dying to try that. Notice here too, by the way, on this one, the trailing parentheses. They're color-coded. Sometimes these are helpful, but you know, one of these, sometimes you look at these and say, oh, let's just start over. And these are sometimes jokingly or snidely, sarcastically referred to as job security formulas. Nobody understands this formula but you. They have to keep coming back to you to fix it or to make it do different things. It's probably not totally true, but you could imagine certain kinds of formulas like this. So, the if function is powerful. It certainly has some limitations. I'm going to go back to that other worksheet, the HR worksheet. Do we have word yet whether Christopher has gotten that particular file, this file?
The file's been sent. It should be in their inbox about now.
Okay.
We've received it.
All right, you might or might not have gotten it yet, but we are on the HR sheet. Now, we will not be using that bonus column anymore. If anybody later needs a copy of this, in other words, wants to go over this again, I can certainly send them a copy of how this might look after the bonus column is finished. But let's shift gears a little bit and scroll to the right, and we want to be viewing columns L down the left-hand side, and then column M. Also make sure that cell P1 is visible. We're going to provide new compensation here for all the entries in column L. Simple formula, any number of different ways to do this. The current compensation amount times this 2.91% in cell P1. If we were to press enter here, as I'm doing momentarily, we're simply getting the amount of the increase. So obviously that's not the full formula. But all we need to do, of course, is add on to that the initial compensation. But most of you know that the issue here, if we start to copy this down the column, all of the L2 references will correctly become L3, L4, L5, but P1 will become P2, P3, etc., and that's not what we want. And it would be a lousy solution to fill in column P all the way down to the bottom with the data in P1. So what do? We need to make P1 absolute. And we can do this at the time we actually typed it, or come back and do it now, possibly. You can click after the P1 in front of it in the middle, or you can highlight it. Doesn't make any difference. We add dollar signs either by typing, or better yet, the function key F4 makes that an absolute address. And that has nothing to do with logic and is not intuitive in any way. That's what you need to do if you want to make sure that this address does not change when you copy it. In a certain sense, you could say it means nothing right now. It only means something when we start to copy it. It means this address will not change. So let's complete the entry here. I'm going to press Control-Enter. And to copy this down the column, double-click the lower right-hand corner. And anytime you copy a formula down a column using that technique, I think almost always you want to be sure it goes down to the bottom. Simply press Control-Period a few times. That'll verify it. You would know if you work with the data enough that you know how deep it is or how many rows it is, and so Control-Period simply moves the active cell around the corners or the edges of a range that's been selected. So it's handy, and we can easily see what's happening here. Now, I want to open the door to a thought, but yet not pursue it. These answers are not exactly as we see them. Behind the scenes are pennies, maybe even portions of pennies. It probably isn't a big deal if we're talking about yearly salaries, but if you go to the Home tab and increase decimals, like that, by the time we get to 3 or 4 decimals, ultimately that money does have to be accounted for somehow. And if you want this to be balanced, what we probably would need to do here is simply insert the round function. Let's do this now, and then later we'll talk more about the round function. Round allows us to take a calculation like this one, comma, and round it to a different number of decimal places. If we want to round this to the nearest penny, that's 2 decimal places. If we want to round it to the nearest dollar, that would be 0. So whatever makes sense. Some yearly salaries are whole numbers. If we put in 2, it's going to go to the nearest penny. No matter how many we increase, or how often we increase the decimals here, it's still going to display the same. It's important to note that these 2 buttons here do not change content. They don't change content at all. They simply change appearance. Let's say we don't want to see the pennies even though they're there. We could not show the pennies, but they're still there in the background. Double-click the lower right-hand corner, and we've got rounding on all these. It simply looks like that. Rounding is more important when you're dealing with smaller numbers and pricing of items. You've got to be sure that they come to a certain even amount, or then you run into problems when you start multiplying them. Now, when it comes to tax rate, in this worksheet here, say off to the right, I'm going to zoom back a little bit. There are 2 tax tables. One's in columns T and U. Let's do something else here. Let's actually get rid of column R. Right-click column R and delete. Okay, there we are. Now, if you had not heard about Excel's table functions or table lookup functions, and if you're trying to come up with a tax rate, looking at that yellow table and the data that you see here, we'd probably say, or could say, the if function is what we need here. In other words, we could compare each of these values, looking down the left-hand side. As soon as we found a bigger value, we'd go back and then move over into the next column and come up with an answer. It would be fairly complex because we'd have to have how many nested ifs? About 10 or so, 9 or 10. It would be very complex. Now, Excel has two table lookup functions. I'm going to scroll to the right momentarily here. Here we've got two kinds of tables. Tables, by the way, are not always either two columns or two rows. Sometimes they're multi-column, multi-row. But this table on the left in column, now it's in column S, is vertically oriented. And when we look up data from a table like this, we use the function VLOOKUP. The other table is organized horizontally. If we look up information from it, we use HLOOKUP. Now I think you can see, just by the simple fact of the layout here, which one fits on an Excel screen more efficiently. A vertical table. There's something else too that we can't quite show you just yet, but many times when people are trying to reconcile different lists on different worksheets, trying to match up names or social security numbers, ID numbers, very often they're looking at large lists that are columnar in nature. In other words, you've got a list of names down in column A in one list, and maybe in another list it's in column A too, but you're looking vertically up and down a column. VLOOKUPs are much more common than HLOOKUPs. So that's what we'll use here. Now, if we're trying to come up with the tax rate in our tables over there, many times the table's on a different worksheet. So we do want to give you one example of how this might work if we're on a different worksheet. But if you're in charge of where the table is and how it's positioned and so on, at least when you're setting up a function that uses VLOOKUP, it's going to be better if this is nearby so you can start comparing the results quickly and easily. When it's on a different sheet, it's just a little bit harder to do. You have to bounce back and forth or change your screen display to see two different sheets, something like that. VLOOKUP is compact, it's short, it never gets very, well, I shouldn't say never, but almost never gets very long. Usually it usually has 3 arguments to it, although it's another example where we see 4. Now, within VLOOKUP, there are 2 major kinds of VLOOKUPs. Sometimes we need to find information exactly. We've got to get an exact match. If you're trying to match up somebody's ID number, it can't be just close enough. It's got to be exact. Any text kind of lookup must be exact as well. In this situation here, we're not trying to find numbers exactly. They're going to fall between these breakpoints. The VLOOKUP that we're about to use right now is called an approximate lookup. And I'll zoom in even more on it. And here too, we don't need to make the column wider ultimately. I will a little bit here. Good enough. All right, equal VLOOKUP in cell N2. And we need to have our compensation amount just to the left of it. If you didn't put in that compensation amount in column M, you can use the one a few columns to the left there. The other value. VLOOKUP.
Does everyone in the audience use the VLOOKUP?
Yes.
Yes.
Here's the value we're looking up. Now, let me ask this question too as we're looking at this. I always ask this when I'm teaching live. What's the expected answer here, and what logic do you use? Most people, as they look at this and they look at the table off to the right, will say 7%. And the logic they're using is, well, we haven't reached the 55,000 level, which would be the 8% threshold, so it's 7%. That's the logic of VLOOKUP. It's kind of the logic that if you do your own taxes and you come to that point where your adjusted gross income, then you go to a table to look up your tax. It's the same general idea. If you have not reached the higher level, then you pay the lower amount. And even if this were, 54,999, it's still not 55. All right, here's the value we're looking up, comma, and here's the table off to the right. Let's go highlight the cells from S1 to T11. We'll show you another way to do this too in a moment. Comma, which column of the table there has the answers we want? It's literally column T but it's in the second column, so we put in a 2. That throws people at first. You'd like to be able to say T or double quote T or something like that. That's not how it works. It's called the column index number. It's the number 2. That's it. We're done. Enter. 0.07 is the correct answer. Most of us wouldn't leave it in this form. You could press Control-Shift% sign, or right up here on the Home tab, there's the percent symbol. Before copying this, we need to do something, or we're going to have some chaos here. The reference to the table needs to be absolute. We highlight the table reference, press F4. Now, that makes the formula look more complex, so denser, and the S's and the dollar signs sometimes kind of blur together, particularly if you haven't zoomed in like this. But nevertheless, that's correct, and that's how we do it. Control-Enter and double-click, copy it down the column. And we've got a bunch of correct answers, and you'll check out a few, of course. Again, you might press Control-Period just to make sure it got copied down to the bottom. It did. Control-Period again, back up top. Now, when you're using VLOOKUP for an approximate match, you must make sure that the left column is in ascending order. The numbers don't have to be equally spaced. Most of them are here, except for the first interval. But when they're out of sync, the crazy thing is that a lot of your answers still might be correct. Now, I'm going to insert a typo on here. I'm going to make the 65,000 here be a 95,000. Maybe that was a typo. I just didn't see it. As I press Enter, watch the answers in column N. Some of them might change, but not that many. And so when you're checking out the results of a VLOOKUP, if there's any doubt, don't just check one of them. Check 2, 3, 4 of them. And then make sure, as you look down the left column of the table, that it's in ascending order. And of course, right now, this isn't. I'll undo, and then those entries in column N will change again, a number of them, but not all of them. So be on top of that idea. In this kind of a VLOOKUP, an approximate match, the left column of the table must be in ascending order. Other column, or in this case only one, but other columns do not have to be in any particular order. They're simply based on the result of the VLOOKUP. Excel jumps into here and gets the answers. Some tables will have more columns than this. Now, another worksheet here is called Lookup Choose. It's a blue tab. It's about 5 or 6 sheets to the right. A smaller example, but it's being used for what we call an exact match. Take a quick look at this. You see a table there. There's some names in column D. These people have been given a rating. We need to look up the rating. Fair should be a 71. There's a VLOOKUP in place in cell F2. If you double-click, you'll see that it looks as if it's doing the right thing. And in a certain sense it is. So far, so good. We're looking at the cell E2's content. That's fair. We're looking in the table to the left. Let me back out here for a second. This is a different use of the table. And I want to go back to our previous example momentarily here. I meant to bring this out earlier, but I'll bring it out now. In cell N2 and in all the others, when we put in the table, remember how I highlighted the cells S1 down to T11. Later we made them absolute. If we know that nothing else is going to go into columns S and T, we can use that as a reference. So I'm going to slide over columns S and T with the left mouse button being held down. And look at that entry. Let me press Enter. And as I click out of here momentarily, I'm going to press Control-tilde so you can see the two entries side by side. This is the shortcut that shows all formulas. Take a look at cell N2 and N3. I haven't yet copied cell N2 down the column, but I can and will, and it's going to be much easier to read. S:(T) means look in columns S and T. It's up to you to make sure that nothing else ever appears in that column except the table. It's a lot easier to read. I'll press Control-tilde again, come back here, double-click. All these answers on the screen and all the ones below are going to be the same. There they are. Easier to read. Again, just make sure nothing else goes into columns S and T. All right. Sorry, I jumped ahead a little bit there. Let's go again back to the Lookup Choose, the blue tab sheet here. Here's a VLOOKUP. Seems to have everything in place. We're looking up the data in columns A and B. We're trying to get our answers out of the second column. Now, you wouldn't know at first, but when you're using VLOOKUP for an exact match, you need a fourth argument. After the 2, we put in a comma. And what pops up on the screen? True for approximate match. Now, we could have used that before, but since it is the default, we don't need to use it. False for exact match. Now, where is that coming from? Did you know that all along? Does that make sense? False means exact match. Well, you can tab it into place if you wish. It will give us the correct answer. Press enter. That's it. That's what we do for an exact match. Now, as an alternate, you can use 0. I prefer that. A small reason is it's less typing. Another reason is that false seems to say or suggest that something failed or didn't work. So why use false? Another reason, too, is that a function we will be seeing called match uses 0 for an exact match. And that's what we're trying to do here. 0 or false, now we get a correct answer. Copy down the column, we should have a series of correct answers. So anytime you're doing an exact match, and that means all situations where you're comparing text, or any situation where you're comparing ID type numbers, they must be exact. You've got to use VLOOKUP in this kind of a format.
Yes, quick question for you.
Yes.
What if the answer you're looking for is in the table more than once?
I was just about to do that. Kit Carson here, somebody put in his, Kit, your performance was just plain lousy. Okay? Doesn't work. Excel can't find that. I had somebody ask me in a seminar once, do you think they'll ever have it so that Excel can look up that word in the dictionary and then see which of these words over here is closest to it as a synonym and then provide an answer? And I said, no, I don't think so. But, of course, that does not work because it's not in the table. And furthermore, look what else could happen. Maybe whoever typed in the word fair up here had a trailing space in it. Those sorts of things happen all the time. That's a failure. It doesn't work. Can't find it. FAR space is not in the list over there. Or how about this? Too many spaces down here for Norman base. Too many spaces between very and good. That's not going to work. How about a leading space? Those always mess us up when we do sorting, but I'll do one up here, put a leading space right there, or 2 or 3, whatever. All these are failing. A quick workaround on these before you, of course, the best thing to do would be to clean up column E, but if we use the function called trim, in other words, if we trim E2, this means what? It does 3 things with the entry. It takes off any trailing spaces, takes off all leading spaces, and also multiple consecutive interspaces get reduced to 1. So if we use this function, not only will it clean up the entry up there, but also all the others except for that entry called lousy. So these are all cleaned up now. Sometimes you need that for getting the data looked at or compared properly. Trim. Isn't perfect, but it certainly helps in a situation like this. VLOOKUP, of course, there are lots of applications for it, and when you're trying to match up names, I've seen situations where, imagine one list has a name like this, and the other list is George Babbitt. How are you going to match those up? Ultimately, there are techniques for doing that, but VLOOKUP is not always the function you'll be using either, but ultimately, when you're comparing lists, you have to think about that. Now, I want to go over just one more sheet here. This is a tax-dependent sheet. This is the green tab. I'll zoom in on this a little bit. This is a much bigger table that we're about to use. If you look at Gail Black there in row 2, who makes almost 77,000, or 66, yeah, 77,000 almost, dependent to what's Gail's tax rate. So the logic we've been using all along would apply. Remember, this is not an exact match here because we're looking up salaries. So we're going back to the first style of lookup. So if you make not 80,000, but above 75,000, we'd be looking in this row down here. And the dependence is 2, so where they intersect right there, we would expect to see the answer 16%. So how do we do that in this case? This is a much, much bigger table, of course, with many columns. We're going to start with VLOOKUP, of course. And we will be using this function. Here's the value we're looking up, comma. Now where's the table this time? It starts in cell F3, right there. It includes all these cells here, across and down, right there. F3 to M19. Now, could we use an entire column reference here? Yes, we could. It's not an exact match, so instead of the F3 and all the way down to M19, why not simply use F column F through column M. Easier to read and easier to backtrack later when you're trying to debug if necessary. Comma. Now the tricky part. Which column has the answer? Gale Black has two dependents. So we're looking at column I, but we've got to put in a number here. Which number is it? If we were simply to put in the number, that's the fourth column from the left. But if we put in a 4, that's not going to work for the next person. Barry Bolte's dependents are 4, and even though it's got a 4 on top of it, it's in column K. That's the 6th column of the table. So the more you think about it back and forth here, the column that we need in each case is 2 more than the number of dependents. So here are the dependents right here, C2 plus 2. Remember, if you've got 2 dependents, the answers are going to come out of column I, which is the 4th column. We need to add 2 to this. So if everything's working smoothly, we should be seeing, as we suggested earlier, it's going to come out of this column right here. It should be 16%. And that's what we get. Again, looking at that, let me zoom in a little bit. We don't have to see the entire table for the moment. There we go. The table reference is F through M. Remember, it's certainly not wrong to do it the other way, where it would be F3 colon M18 or whatever it is. But this is the tricky part sometimes. Now, this is one context. In a different context, many, many times when you've got a set of numbers like this, you don't have a 0 in it. So based on the nature of the data or what it might be, another kind of parallel or similar situation, maybe it'll be C2 plus 1. But if we copy these down the column, and we'll check out a few, of course, and any one of these. Here's Jana Brennan right here, 10.7%. 66,000 means it's going to come out of this row right here, and 3 dependents, 10.7%. That's what we get. In all cases, the column number we need is 2 greater than the number of dependents. And there are no hard and fast rules about how you set these up. And go to an Excel book and try and find this example. You won't find this one. It just reminds us at times, though, we have to pull together logic in different ways to come up with different results here. Now, 2 sheets to the right, it's a sheet called Master List. And there's a Social Security number in cell G2. By the way, that Social Security number and all the ones in column C look like they have dashes in them. But when you click on them and look in the formula bar, or if you happen to double-click any one of them, they do not have the dash. They've been formatted. And let me bring this out. Example here. If I put in a 9-digit number here, if that's a Social Security number, don't bother typing the dashes. Simply press Control-1. That'll take you to format cells immediately, or rather fast. Control-1. And when you get there, there's always a lag when you first, for some reason. There isn't usually a lag. There we go. You'll see a choice here called Special, and there is Social Security number, and then OK. Always use that instead of the dashes. The dashes involve more typing, and also when you're making comparisons, and I've seen this a lot, people are comparing this kind of a Social Security number with another list somewhere where the list actually has the dashes in them, and you can't match them up. It's better to put them in this way without the dashes and then apply the format. Remember, no dashes there. Okay. So we want to match up this one with something in our list here. Let me rig this a little bit by pulling this up on the screen. It's in row 16. We can see that ahead of time. I'm going to drag this upward with the Shift key just to put it closer to the top so we can see it. We don't care about being sorted or anything. So it's up there. I can possibly zoom in some more too. And actually, I'll move it over here. There we go. Now, sometimes, and imagine when this might be on a different sheet, might be here, we're trying to see if this exists. Now, maybe this is a huge list. Does this exist in column C? Equal match. Left parenthesis. Here's the amount in question, or not the amount, but the number in question, comma. Let's look in column C, comma. If we're looking for a number that's closest to but less than, and we never do that with Social Security numbers, but if we were with other numbers, we put in a 1. If we're looking for a number that's greater than but closest to, we put in a -1. So this is an exact match. We put in 0. And that's one of the reasons I also use 0 for VLOOKUP, because we've got some consistency here, even though logic says, why don't we type exact or something. Anyway, 0 will work, and this will tell us by way of where it appears in column C. It's in the 9th position. And since we chose the column, the entire column, that's exactly equivalent to the row number, row 9. There it is right there. If you don't find it, or let's say in this case if we didn't find it, a different number up there, here's what we get. NA, did not find it. Possibly you might want to use an if function to say found or not found. You could do that too in combination with match. Let me undo this. Now, what if the task here ultimately a little bit different, and that is we want to get the name of this person. Let's also imagine the following. Maybe this is a so-called master list. It's used by other worksheets in this workbook, maybe by other files. We cannot change the order of it. In other words, we can't move the columns around. What we'd like to do, in effect, is a leftward VLOOKUP. In other words, taking this value, let's look leftward and get the name. You can't really do that. Now, if you do have the luxury of moving the columns around, sure, do that. You can do your VLOOKUP. But the match function here, and let me oops. There we go. I want to bring that back again. We can use this indirectly with another function. Another function that we use sometimes in looking up information from tables is called index. Index begins with the location of a table. Let's start this way by looking in the table in columns A, B, and C. That's where the data is. By the way, they use the term array. We've got some cells somewhere, A through C. Comma. Which row number do we want to pull the data from? The row number 9. So I'll just click up here on the 9. Remember, that's where the match function is. Oops. Sorry, didn't mean to hit enter there. Comma, and we need to put in the column that we want to get the answer from. We've got the row. It's row 9, column 1. Enter. Terry Moy. And of course, we see that there. Now, any book that covers functions in any depth usually mentions the index function and the match function. The mention of one refers to the other and vice versa. Many times these are used together. Now, in a certain sense, we're using them together right now, but what I'm going to suggest here, what if we go into this cell? This is the match function. Simply highlight this, press Control-C, escape. Let's come back in here and highlight the E3 here, and press Control-V. That's a match inside of an index. Now, if both of these are brand new to you, it's like, whoa, what's going on here? Heads are swimming a little bit, maybe. But this will work, and we'll get our answer. And we wouldn't need this anymore. Now, it can be even simpler in this particular case, too, because at the time we're looking at the table, we really only need to be looking at column A. So the index function portion of this really only needs to be looking in column A at that point. Match has told us it's row 9. It discovered that by looking in column C, but that works fine here. And if our table is only a single column, we don't need the column reference out there. Get rid of the comma and the 1. We'll still get the same answer. So match and index give us some capabilities here for matching up data, and sometimes you'll run into little blocks too with VLOOKUP in other cases, and we'll likely see one a bit later too. And sometimes you'll have to use the match function. The index function can be used by itself. The next worksheet over is called index. Here's a list. Maybe it relates to shipping of packages. Packages maybe are by weight, by size here. And depending on where they're being shipped, you've probably seen something like this at a post office. We've got a bunch of items listed by item type in column B. Column Q has the sizes. Column R is the shipping zone. We want to know the shipping cost. So looking ahead here, if an item is of size 5, shipping zone 4, we're looking down here somewhere. There's shipping zone 4. That should be $31.49. We'll do this with an index function. Equal index, left parenthesis. Now the table here is just these cells right here. And we do have to highlight specifically. Comma. Which row do we get the data from? The row relates to the size, so that's coming out of cell Q2. comma, and the shipping zone right here, coming out of these columns here, the column reference is going to be right here, 4. So we should see that answer, 3149. And there it is. And as is frequently the case in these situations, we need to make this cell reference absolute if we're going to be copying it down the column. F4, Control-Enter, double-click, we've got it. Always check out a few answers, of course, and it should be working just fine. So sometimes index is used all by itself, and of course sometimes matches too, but it's not uncommon to see them being used together. Now, there are other kinds of functions. It's hard to come up with a master list of functions that everybody needs because we all work with Excel a little bit differently. So I mentioned round earlier. Take a look at a few of those too. We also want to show you a particular kind of function called an array function or an array formula. Earlier we did rounding. Let's point to something here where it wasn't used and point out a problem with it. We've got some items in column A. We don't need to see the item numbers really, but we got some pricing there, and all the items are being increased. This is pretty much what we did with the salaries earlier. All the items are going to get a 4.36% increase. So this item is now $9. Now, maybe these are office supplies. That's a box of pens or something. Somebody orders 10,000 of these. What's going to be the answer to that? You know ahead of time. It's going to be 90,000. But it isn't. And somebody has to account for that $41.68 out there. Where's that going? Or where didn't it go? So on. Is this $9? Well, apparently it isn't. Let's go to the Home tab and increase the decimals. Now, I said earlier, this does not change content. In fact, as I increase the decimals here, the formula to the right will not change. I'm just showing more decimals. Here's the real answer. So whoever wrote the formula just didn't stop to think about the fact that there are portions of pennies left over there. And in the short run, that doesn't make much difference, but in the long run, or in bigger orders, of course, it's a difference. Percentage-wise, it's not much, but still, it's money that has to be accounted for. So what should have happened here? The round function should have been used, as we did earlier with the salaries. And here we probably round these to the nearest penny. That's 2 decimals, comma 2. Copy it down the column. Now, we're not going to leave it looking like that, but again, it verifies what actually happened here. Had the other person who wrote the formula looked ahead of time at this and possibly the other answers, he or she would have seen those other decimals out there. Now, there's some variations on this. We'll come back to the first one. If we wanted to make sure that this always goes up to the next penny, we use round up. In other words, this doesn't use standard rounding. It goes up to the next penny. Now, I'm going to drag this down slowly to the next entry. Does it change? No. How about the next one? That goes up to 435. And so some of these will change, some of them will not. In other words, it's moving up to the next penny based on the calculation. We're not seeing the interim calculation. You can see the interim calculation, by the way, if you double-click on a cell while editing. For example, we could highlight this right here and press the function key F9. There's the real result of that. But if we do a round up, it goes up to the next penny. Let me escape here and you see it. It went up to 5.11, even though it was closer to 510. That's what round up does, the round up function. Round down, of course, does the opposite. And the thing to remember here, round down is what we do with our ages. If you're 39 years and 11 months old, how old are you? Well, you're 39. In fact, even before your 40th birthday, you're 39, right? So we always round down with our ages. And you could possibly have used that here too. If I do this here for the first entry, of course, it's going to be $8.99. Now, every time I make these changes, now the formula to the right is changing. But increasing and decreasing the decimals has no impact whatsoever on content. And there are people that do mistake that button for changing content. It does not. Simply appearances. Another use of the round function could be over on salaries here. Yearly salaries often are whole numbers, so the 12 cents there, not a big deal. We might say, let's just round this off to the nearest dollar. So if you want to round it to the nearest dollar, it's comma 0 at the end. So we'd have that kind of a result. Here too we could round up or round down. Now, one company that I work with, I don't know how they did their calculations, but I did recognize that their various salary levels always ended in 2 zeros. So if they were working off of old salaries out of the past maybe and always wanted them to end in or be multiples of 100, they possibly could have used a -2. That rounds to the left of the decimal, 2 places to the left of the decimal. So as I drag down a few of these, next one's going to go to 200, next one's going to go to up to 600, and so on. We're rounding to the nearest $100 if we use -2 out here. So interesting things we could be doing with rounding. These are things you wouldn't tell the employees, of course, if you're rounding in a certain way. But we could use round up and round down too. And here's something a little strange, and I guess I saw this referred to once, didn't see it actually done. If you get paid 24 times a year, 26 times a year, look, it's 26 times. You get paid every 2 weeks. If that gross pay isn't, if you want that to be an even amount, you could round these to the nearest $26. But anytime you want to do rounding that's not a factor of 10 or multiple, a decimal percent there, we use mRound. So we could round this to the nearest $26, and that would mean that every paycheck, its gross pay, would be an even number. So all these numbers here that I drag across, all those answers there are multiples of 26 because we use mRound. If you want to go up here, you might think it would be mRound up and mRound down, but it's not. It's completely different. If we want to go up to the next $26, no matter how close it is, we use ceiling. And you can imagine what the other one is. To go downward, it's floor. So those are variations on the mRound function, which lets us round to other values. An example back here with this data, we could possibly want to round these to the nearest nickel. Up or down, ceiling, floor, but it's just the nearest nickel. We'll put in 0.05 out here. So there could be times, so if I just copy a few of these are all going to be multiples of 5 cents that is. And so we see those there too. mRound. All right, some other functions we want to look at here. The COUNTIF function, SUMIF function, I believe I mentioned one of these yesterday. These work well with large lists. If we go back to the very first worksheet, HR, or possibly HR stats out here. Let me scroll to the left a little bit. This is the second worksheet, which we didn't actually use much of. Somebody might be looking at this list and just kind of casually says, how many full-time people do we have here? And we can easily calculate that with the COUNTIF function. We're looking in column H, once again, using a column reference, comma. We can either type double quote, full-time, double quote, or if it's in a nearby cell, like it is over here in P7, we can use that to count. Double-clicking will get our count of the other kinds of employees as well. So many times simple, straightforward. One of its companions is SUMIF, also AVERAGEIF. Both of these, I'll use AVERAGEIF, allow us to get data from an additional column or additional set of cells. These are not always columns, by the way. It could be a range of cells. The final argument in an AVERAGEIF and SUMIF is the data that you want to be tabulating. So if we want to get their average compensation, we'll click column J here. So the average compensation for all people, or all records that meet the criterion that it's full-time is this. That's a total. Control-Shift exclamation point is a quick way to format that. That would be helpful. Okay. Now, there are 3 new functions as of Excel 2007. They end in the letter S. So there's AVERAGEIFs, SUMIFs, COUNTIFs, and they allow us to put in multiple criteria here. So that, for example, here, if we wanted the average salary or compensation, here, oddly enough, after changing the function to be AVERAGEIFs, that's an S there, we first put in what we're trying to tabulate. Let's say it's the compensation amounts in column J, comma, and then we have pairs of criteria, or you could say this is a criterion, I guess. Column H is full-time, that's one. Another one might be, I'll point up here, the job rating, that's column K, comma, is 5. That's our highest rating. So all people who meet these two criteria, you can have up to 31 sets of criteria here. So that's 2 pair there, 2 sets you might say. And we can go further. Comma, let's take a look at their years of service. It's in column G, comma, all those above 9. And you wouldn't possibly expect this. Double quote, greater than 9 double quote. So now we got 3 criteria there, that way. Let me momentarily make this pretty narrow and pull this over a little bit and maybe zoom in a little bit too, so see that a little bit better. And off to the right. So, average ifs. So these are ideal for tabulating data out of large lists. They can get pretty long too in some cases. And again, we could be doing this with the COUNTIFs. We simply want to know, for example, how many of our full-time people have been here more than 20 years and have a job rating of 5, something like that. So COUNTIF, SUMIF, and average if, and then the 3 companions that all have an S at the end of them, are pretty valuable tools for tabulating certain kinds of totals. All right, some other kinds of functions here too that we want to look at. Date functions. I've got a worksheet here called dates. It's a blue tab. It's a bit to the right here. Many times, day of the week is important information. Let me jump back for a second there. There we go. Day of the week is important information. A disappointing function at first. We want to know the day of the week here. Equal weekday. This is in cell B2. This is on the dates sheet. The weekday of cell A2. Type it or click on it. There we go. 4. Well, 4 means Wednesday. You wouldn't know that right away, but 1 means Sunday, and so on. Now, the reason it's a number is so we can build formulas off of it in certain ways. It's going to be valuable that way. But I think most of us also would prefer to get the actual day of the week printed out here. So nearly always, it seems like, when you're using this, you want to jump right into Format Cells. Now, again, you can right-click and go to Format Cells, or Control-1. Get you there fast. Control-1. It's on the Number tab under Categories. Go down to Custom. And under the word Type, you're probably going to see the word General. Highlight that and put in either 3Ds or 4Ds. If you put in 3Ds, you're about to see WED, 4Ds, and the preview above it suggests that we're about to see Wednesday. There it is. Double-click, copy that down the column. We know what day of the week it is for the others. Handy information. Think of how valuable it is in some environments. Do we do more selling on Fridays or Saturdays? Do we get more orders on Tuesdays, Wednesdays? How about shipping? It's our busiest day. Things you need to know about workflow. Some other date functions off to the right here. By the way, everything we do with date functions work properly, provided the date entries are done in a standard way. When you're typing a date, use slash or dash. And if you need today's date, just press Control semicolon. Control semicolon. You'll get today's date. That comes in handy a lot of times. Now, off to the right here, columns F and G. Also, let's keep column D in view. That's a list of our holidays, current year and some into the next year. A project started on May 20th. It ended on September 3rd. How many days passed? Now, if you simply subtract the two, and that's a valid thing to do at times, you'll subtract the later date minus the earlier date. That would be G8 minus G7 here. So how many days actually elapsed between those two dates? 106. I'll move this over here. If we want working days, though, we're going to use a function called net workdays. And because this is so long, as soon as you see it in the list there, you might as well click it and tab it into place. There you go. Starting date is in G7, comma. Ending date, G8. Now, if we simply press enter, that doesn't count the Saturdays and Sundays. It was 77 working days, not 106. We do have holidays over there. Let's include those too. And we need only, we can highlight all of them or just the relevant ones. So following the G8, put in a comma, and in this example here, we can highlight just those. Or I highlighted an extra one. It doesn't make any difference if you include more. That's fine. Just make sure you include the relevant ones. So instead of 77, it's 74. So net work days. If you saw that in a list and you pronounced it network days, you might not think what it meant. But anyway, there it is. That's handy. The reverse of this is work day. For example, project started a few days ago on November 3rd. It's a 45-day project. When will it finish? If we simply added the days, it'd be like something like December 18th or whatever. But we want to not count Saturdays and Sundays and not count those many holidays that are in there too. Work day. So we've got it. Okay, it's work day. There we go. Starting date, comma, number of days, comma, and let's not count those holidays. What's it going to be? January 13th. So you've got your holiday list nearby for that sort of thing. Now, there's another date function that's very strange. It's very good, too, and yet it's got an oddity about it. Let's go back to the very first worksheet, HR. And off to the left, in column G, I'm going to make it wider. You don't necessarily have to do that. There's a formula in column G called dateDiff. DateDiff allows you to calculate the difference between two different dates. Now, there's something else going on here, too, that's unusual. The function today, and it means today, this is a moving value. It changes every day. So at any given time, when you look at this list, you know it's accurate to the day. How many years has this person been here? Now, this counts years in the same way that we do birthdays. Let's say we change the second one here, the second person in F3. Let's make that be November 14th. How long has that person been here? 11 years. Quick math says, well, wait a minute, 12 years. Well, not 12 years yet. 12 years next week sometime on the 14th. Not now, a week from today. This does it to the day. In fact, even if we made the higher date be 11/8, it would still come up with the answer 11. So that's how it's working. Now, this is a moving target, and because this list is about 700 names, you could say, on average, if we open this every day, what has happened from the previous day? 2 of these entries changed on average. 700 days over a 2-year period, let's say. But the point is, that's an easy-to-use function. And if we were tracking equipment, say that's an installation date, we want to know how long the equipment has been there. Maybe it would be more useful to put in M for months. How many months has that person been there? This person's been here 25 months. Not 25 full months, but 25 full months and maybe some more over. So we say it that way. So, and we can use, instead of M here, we could use D for days. By the way, try this with your birthday. You'll find out how many days old you are. That's interesting. And without going into all the detail, there are 3 other variations. There's a YD, which means how many days since the last yearly anniversary. There's an MD, how many days since the last monthly anniversary. And then there's another one. There's a YM, how many months since the last yearly. Let's get a little more involved. Now, here's what's odd about this. I think it's a great function for this example here. It's perfect. And by the way, if you have a list and you're showing age, it should always be a formula, and perhaps a formula like this. You never want age to be a static entry. Although at certain points when, for example, the age at time of loan, of course, that would be static. Now, here's the weird thing about it. You see this function, you say, oh, interesting, I might use that. In fact, I'll write that down, whatever. A week later or so, you come back to the Formulas tab. This is where we go sometimes when we're trying to track down a formula. And they're categorized here. Oddly enough, you don't see statistical at first. Eventually, you'll come to more functions. There's statistical there, and there's a ton of them, no question. And there's lots of categories here and lots of functions, over 450, as we said. This time, we're going to go to date and time. And where's dateDiff? It's not there. There's no documentation on it. But it works, and it's there. And it's been there for years. If you're using the Mac version of Excel, the documentation is there. It is referred to. If you type this in, you'll notice something else. Most functions, as soon as you put in the left parentheses, except this one, give you a prompt. This simply says dative as if somehow that's meaningful, but it doesn't give you any kind of a clue as to what you put in here. So very strange as to why this is not documented. And I think the underlying reason is that there is a tiny bug in it, and it only happens if you're tracking days and months comparisons from late January into early March. But anytime you're using Y for year, M, or for month, D for day, it works just beautifully. And it's the ideal function for this example here. All right, there is another kind of function, another kind of formula called an array formula. That's A-R-R-A-Y. Let's bring this out. In this worksheet here, we've got some totals in column E. Each of these entries right here, simple formula. This is the worksheet called arrays. We're multiplying the two. And then at the bottom here, we're adding these up. Now, there could be situations, maybe not this one exactly, but where you might say, is there a way to somehow to take all of these times all of these, meaning multiply those, do this one by one, and add them all up all at once? Well, let's try this and see what might happen. Maybe just below it here. Let's put in equal sum, left parenthesis. Let's highlight C2 down to C10. Asterisk, meaning, of course, multiplication, and then these. If we press enter, we don't get an answer. Let's go back again. It seems like we should be able to do that. We could be able to do this. We want to perform 72 times 52.99 and 18 times 62.29, on and on, over and over. It will work if we press Control-Shift-Enter. Not Enter, Control-Shift-Enter. It works. There's our answer. It's the same answer as this, just hasn't been formatted yet. If you look in the formula bar, the formula is embedded in braces. You don't type the braces. If you edit the cell, either in the formula bar or in the cell itself, you don't see the braces. It almost sounds like I'm making this up. I'm not. It works. By the way, this wasn't truly needed here. There is a function called SUMPRODUCT that would have gotten the job done for us just as easily. In this scenario, though, the idea is we don't want to have to do the individual calculations, so we wouldn't even need that there. If we took that out, we still got a correct, or have an answer here, and it's the same one too. Let's move to the right and do something here. Now here, there is no alternate function to use. Similar kind of situation. Each of these formulas here is subtracting those two to come up with how much time has elapsed between ordering and shipping. The items in question here maybe require a certain amount of assembly time and then packaging time before they can be shipped. So we see the numbers here and so on. So let's do an average. Let's just do it out here maybe. Let's try and do this in the same kind of way. Each of these formulas is subtracting the two. What if we could essentially say, do all these subtractions and then average them? Equal average, left parenthesis. Let's take all of the shipping dates minus all of the order dates. If you press enter, you might get an answer. The insidious thing about this is that sometimes you get a believable answer. Now, if we hadn't seen the other answer down here that tabulates those averages, that could be believable, and I think it wouldn't be in this case, but sometimes it could be. But to get the correct answer, we need to press Control-Shift-Enter. And that's the same answer, although it doesn't quite look the same as the one down here. That's the correct answer. Looking in the formula bar, we see the braces. If we double-click to edit, we don't. Now, what both of these have in common is the idea that array formulas, and this is not exactly a definition, but most array formulas are handling data in parallel kind of fashion. And that's not exactly a definition, but what we're trying to do here, and you saw what's happening, we're going to take K2 minus J2, hold on to that result, then K3 minus J3, and, one by one, all the way down to row 13. But by pressing Control-Shift-Enter, it's as if we're saying, make this work in kind of parallel fashion. Now, I've never seen it quite described that way in a book, and I don't think that's the official way of describing it. That's kind of the way I think of it. But there are broader implications for this concept, too, as we work with other kinds of data. And certain functions are called array functions. Let's complete this again if you haven't. Control-Shift-Enter. Let's move one sheet to the right. Frequency. There is a function in Excel called frequency. In column A, we've got a bunch of Social Security numbers. Let's zoom in on this maybe a little bit. We've got a bunch of salaries there. And in column E, and somewhat arbitrarily, is something set up. It's later going to be referred to as a bins array. We'd like to see a breakout here of how many salaries below 20,000, how many from 20 to 30, 30 to 40, and so on, like this. This interval, or these sets out here, could be differently spaced. They probably wouldn't be, but we could do, every 15,000, every 5,000. We probably know the upper and lower limit ahead of time, but we set this up ahead of time. If we'd like to get a frequency count for each of these, we're going to put in the frequency function right here, and we highlight these cells together first. Now, to the right, and just for visual reasons, I've got a chart set up that will display the results here. But a little bit different here. We highlight the cells ahead of time. Frequency is an array function. It needs two arguments. The first one is the data. And in this example, we can simply click column B, comma. Now it asks for the bins array. Let's highlight this data right here. We're not going to press enter. We press Control-Shift-Enter. And we have our answers, and the chart gives us the visual on it as well. Now, every time I use this, I have to kind of stop and think. The 4 next to the 20,000 means we've got 4 entries in the list that are up to, but not up to and including 20,000. Let's click in. I'm going to click in column B. If you go to column B and do an AZ sort, go to the Data tab in the ribbon. We can click AZ here. See what's happening. We've got 4 of them there. Now, if one of them is exactly 20,000, I'll put this right on the border. Watch the list to the right. That's included. In other words, we've got 5 of these now that are 20,000 and under. So that's what that number means. We've got 59 entries here that are above 20,000 up to and including 30,000 and so on. Now, here's what could be interesting about this. If you use different breakpoints, you might get a different chart. Now, we don't always necessarily have charts with our data, but if I start this at 15,000, and then and right away that won't cause a change yet. Or yes, it did cause a change. And now I'm going to put in 25,000. But then I'm going to copy that interval downward. The frequency will react. So I'm going to have to over just a tad. Now, that's a totally different chart than we saw before. And we're not lying, we're not cheating or doing anything irregular or inappropriate, but just on the basis of breakpoints. Now, imagine in certain situations, if it's your data and maybe you're trying to prove a point or whatever, and it could be something other than salaries for sure, but just by using these different breakpoints, you could get a different display there. And of course, these are in sync with the numbers that we're seeing right here. Notice something else too. If I press Control tilde, and I will, to show all the formulas, let me zoom in, Control tilde, these are all the same. That's kind of surprising. And can you delete one of them? We go back to the normal display here. I'm going to click here and delete that. You cannot change part of an array. It doesn't say why, but it just says you can't do that. So odd. It's as if when we use these formulas, these kinds of functions, they have rules of their own. But you
I have a quick question.
Yes.
When I was first typing in the formula on my sheet and following you, I accidentally did Control-Enter instead of Shift-Control-Enter, and
yes.
I came up with different results. Why is that? What's the difference between the Control-Enter and Control-Shift?
Well, let me see if I can do that, because if imagine I'm typing this, and I press, well, maybe I'm making a change and so on. Let's see. If I press Control-Enter, yeah. If you don't press Control-Shift-Enter, let's see what it did do here. It tries to use a different range each time.
Oh, okay.
I I don't know what these answers actually would refer to. I'd have to analyze it for a bit, but it is not an array formula unless you press Control-Shift-Enter. Yeah. So you do that. Now, if you wanted to somehow refer to a different range, or you can't delete one of these, but you can delete them all. In other words, we can do that. You can certainly delete them all, but you can't delete just one. You have to delete all of them if you wanted to start over. Now, recognize here, as I backtrack here too, if you're simply changing the bins array, you don't have to do much. But if you say, I want to expand this because I think we got salaries over 95,000, if you do this, you can't really. Can I copy this down to here? No. So in that case, you would delete all these and then start over again, equal frequency. So bins array, or the data's in column B, comma, and now the bins array maybe is grown. Control-Shift-Enter, and maybe we did need that. But again, when the intervals were at the 1,000, at the 20,000, 30,000, etc., we had a different looking chart there. So that you could do some interesting things with that. Here's another one. If you go two sheets to the right, here's a line chart. Now, some of you may know if you work with charts, if you want to produce a trend line here, you can right-click on the line and add trend line, and it automatically puts in a linear trend line right there. If you want to put in exponential, you can choose that. Now, you probably wouldn't be doing this unless you know something about regression analysis. And in either case, you do get a line there, and it could be, you could have two of them. You could change their colors and all that and make them look the way you want. But sometimes you need to have actual data that duplicates the line. We have a line there, but we don't have any numbers to go with it. And so there are two functions. One's called trend, one's called growth. Both of them allow us to, in effect, create a set of numbers that would match this. So I'm going to take out this linear here, because we're about to see a real line here with real values right there where we see this entry. So I'm going to press Control-Z a couple times, get rid of it. So here we're going to highlight cells C2 down to C31 and type equal trend, left parenthesis, and then we highlight all the data from B2 down to B31. And it's going to be Control-Shift-Enter. And there's the line. And we have actual numbers to go with it. If you had these numbers somewhere and plotted them, it would be a straight line. If we want the exponential line, we use the growth function in the same way, and we do it here in column D, equal growth. We refer to the sales entries right here, Control-Shift-Enter, and that's the green line, the growth line. Let me momentarily just show you the functions up here in both of these cases. Well, but just press Control-tilde again to see them. So in column C, we see trend. It's simply referring to the sales data over in column B, and the growth function doing the same thing. But both of those are array functions. We press Control-Shift-Enter, and notice how in each case, down the column, it's the same function over and over and over again. Now, I don't want to go farther with that. I'm not sure how many people use that, but it does bring out another aspect of certain kinds of array functions. All right, there's another worksheet here called Aggregate. Let's move back there. I meant to bring this up earlier, but we can bring it up now. There's a worksheet called Aggregate. And there's a new function in Excel 2010, overdue. First of all, on this worksheet called Aggregate, recognize that in column B, there's some problems, some errors. And we don't have time to clean them up, and maybe column B is thousands of cells deep, 1,000 rows deep or whatever. Here's a formula in D2. Doesn't work because there are errors in there. Now, the function that does work is called Aggregate. Now, what if I told you that and had to run or something, didn't give you the details, and you come back like, what was it? Aggregate. I think I'll look that up. Formulas tab. You wouldn't find it at first probably, but it is a math function. But aggregate, what's the description? Returns an aggregate in a list or database. Well, that tells me everything I ever wanted to know. That's a pretty poor definition. That's what we want to use here, though. As soon as we start to use this, you'll begin to see what it can do for us. It will let us come up with the totals, by the way, ignoring the errors. Equal aggregate. Here, too, you might tab it into place as soon as you see it. Oops, I forgot to do it. Try it again. There we go. And we get a list of 19 entries here. Now, once again, we might be saying, boy, this is not exactly user-friendly, is it? What do we want to do here? We want to do sum, therefore it's the number 9. Now, this list could be familiar to you if you are familiar with the subtotal function, because you see the same kind of list over there. So if we want to do a sum, we put in 9, like we all should have known that. Now the next part gets more interesting as soon as we put in the comma. We've got 8 choices here, 0 through 7. If we want to ignore error values, we put in a 6. Note some of the others. Some of the others allow us to ignore data in hidden rows. So that could be a value. Some of them a combination of the two, and some of them that might use other subtotal or aggregate functions. So I'm going to put in a 6 here. Ignore error values, comma, and then finally, what are we trying to tabulate here? The data in column B. Just click column B. Now we get an answer. You just got to if you use this frequently, you will know 9 means sum. That's probably the one you'd use most often anyway. 6 means don't show the errors. Or, I mean, sorry, bypass the error cells. Now, if we want to do that for average, I'll just drag it over here. But the difference here, average is a 1 instead of a 9. And we, again, would want to be looking at column B again here. So the average, ignoring the errors, is this. And similarly over here, for max, we'd have to, again, type in the function. As soon as we put in the left parenthesis, we get our prompt and so on. So I think it's a valuable tool. I've used it a lot already. I just don't have the time to clean up all these errors at times. I went under the total of everything else. It's not an error. And so that's the function. Now, just to the left of this, let's see, we've got a couple of functions here. Let's see. I don't have time for a whole lot. I'm trying to figure out which one will fit best here and what we want to do. We saw this list yesterday when we were talking about some of the database features of Excel, and I don't want to repeat what we did there, but we do have this ability when we're looking with data here to change it. And I also mentioned the new flash fill feature in Excel 2013 that you might want to consider using. But there are a couple of other thoughts here too about other functions. Here it is, match names. That's what I was thinking of. What if you had a list like this, and on another worksheet you had a list like this, let's say, and you need to get the salary here for Susan Carr. You can see over here it's $69,000. So first thought here, we're going to try VLOOKUP. I guess I got caps lock on, but yeah, it won't hurt. But right away we're kind of stymied because we need to somehow pull together Susan and Carr so that it looks like Carr, comma, space Susan. Well, we can do that. In other words, we can get the last name. That's Carr right there, followed by the ampersand symbol. It means and then double quote, comma, space, double quote, and then Susan. So what we're trying to do here is, I'm not finished yet, so that's why. There we go. Another ampersand. There we go. And Susan. So that looks pretty weird, pretty geeky, but what is this doing? It's grabbing CARR, comma, space, Susan. That's what the name looks like over there in column F. Comma, that's what we're trying to compare. So all of that together. And where's the table? Columns F and G, comma. We need to get our answers out of the second column, comma, and it must be an exact match. And if everything goes well, it's going to be that 69,000 entry. It is. So once again, it's a little wider so make sure you can see it all. There it is. So sometimes you're going to have to do something like that. Pull together data from different cells. As I double click and copy this down the column, We do have some correct answers. Now, Alan Forrest just is not in the list there. There's Adam Frost, probably a misspelling of something, but the others are found. We can check them out. So, now, how about the reverse situation? What if you had a list like this, and you need to get, for example, Juan Garcia's ID number? Now here, let me make column E narrower for the moment. Coming up with an ID here. If you start VLOOKUP, I think right away you realize there's a problem. We're trying to take this name, Garcia, comma, Juan, and then compare it with the table over here, where the names are in separate columns. And there's no real construction we can come up with here for VLOOKUP that's going to work. We can't use VLOOKUP here. But we could start with match. We could say, in effect, let's take this information here, Juan Garcia, comma, and match it up with, and this will involve an array formula, what's in column A. Those are all the last names, followed by ampersand, meaning and, double quote, comma, space, double quote, and what's in column B. And we might want to make sure that's an exact match. 0. See if this works. Juan Garcia. You look over there at row 6, we hope. We hope we get a 6 here. Oops, that didn't work. Why not? It's an array formula because we're trying to pull together data from different cells in column A along with the comma space and different cells in column B. Again, that idea of pulling data together in a parallel way. Control, Shift, Enter. 6. We got our answer there. It's in the 6th position. So that helps us. But we're still not there yet. We have to then take that information and use index. So when we use index, we're saying we've got a table somewhere. And for the moment, we can say that table really is over in column C, comma, and we need to get it out of a certain row. And we don't need any column reference because it's only a single column table that we're referring to. Now the right parenthesis out there, Control, Shift, Enter. Now if this is all working smoothly, we should get B0318. And that's what we get. So that's a combination of index and match and an array formula all together at once. And that's necessary sometimes. If you're trying to do this when you're on a different worksheet, this is all the more difficult. If, for example, here, if I were to, and I could actually do this, I'll take a name here. How about Susan Carr? What's Susan Carr's ID? What if I copy this to another worksheet? I'll just do a Control C here and maybe jump down to the previous worksheet, trend growth, go off to the right, an empty spot somewhere. Zoom way in and just pop that name in there, Susan Carr. What's Susan Carr's ID? Equal match. Now, how do we're going to take this and match it with the data on the other worksheet? How do we get over there? We click on the other worksheet where that's found. Here's match names. And then what do? We need to get column A out of there, followed by and then double quote, comma space, double quote, and column B, that's where the table is, comma, 0 for an exact match. And once again, and look how much longer it is. I didn't press Control Shift Enter, now I will. So it's coming out of row 2 where it belongs. So it just makes it look much more difficult. And by the way, if sheet names have a space in them, you'll also see a single quote around the name. So although writing formulas across different sheets certainly are necessary, you see what happens sometimes in adding to the complexity of this. And to complete this, I should press Control Shift Enter there, but okay. Keep missing the key. We need to add index here, so let's move on with it. But like before, when we want to add the index portion of this, I have to click back on the other worksheet here and click column C, comma, and then I'll have to go into the formula bar here and put in the final right parentheses and Control Shift Enter. So her ID should be A0094. There it is. But, it just makes things look a lot more complex. Now, you don't always have the luxury, I certainly don't either, of moving data from one worksheet onto the other one where you're trying to do the matches. But this gives you the idea of some of the complexity involved and some of the help that these array formulas are going to give you.
At this point, we'd like to thank everyone for attending today. And if you do have any further needs in terms of consulting, programming, or training, you can always reach us at www.excelandaccess.com. Dennis, thank you very much for another terrific training session today. And thank you, Florida Peninsula, for your attendance. Take care.